Number 12 asks us to convert this equation from rectangular form to polar form. So I'm going to show you two ways to solve this. I'm going to start with the shortcut version. And the way to do this easier, quicker, is to start off by graphing this. We can recognize that this is going to be a circle. This is the general form in rectangular form for a circle is x minus h squared plus y minus k squared equals r squared, where the point hk is the center of the circle and r is the radius of the circle. So given that, we can see from this that our h here is 2. We've got x minus 2, so h is 2. And y, we're not subtracting anything from y. This is y minus 0 squared. So our y is 0, or our k is 0. So the center of this circle is going to be at the point 2, 0. And the radius here, this is r squared. So we take the square root of this. The square root of 4 is 2. So the radius is 2. And now we can graph that circle. So we just go to the point 2, 0, right there. And then we draw a circle with a radius of 2. So we'll come out to here and around to there. That's a circle with the point, with the center 2, 0 and the radius 2. So that is the graph of this equation. Now, in order to put it into polar form, we just use what we know about graphing circles in polar form to come up with the polar form of the equation for this circle. And we know that the polar form is always going to be r equals a times either sine or cosine of theta. So r equals a sine theta or r equals a cosine theta, where a is going to be the diameter of the circle. All right, so this, since it's symmetrical on the x-axis, we know that this is going to be cosine. So we can get rid of the sine. This is going to be r equals a cosine of theta. And we know it's positive because it's on this side of the y-axis. And now all we're left to do is fill in this a, which is going to be the diameter of this circle, which is 4. And so that's our equation, and that's the answer that we were looking for in this problem. So if that makes sense to you, you can stop the video right now, because that's, if you show me this, that's full credit on the exam. But if you would like, I'm also going to show you how to solve this algebraically. So let's go back up here to the problem we had in the beginning and replace x with r cosine theta, replace y with r sine of theta. So this will be r cosine theta minus 2 squared plus r sine of theta squared equals 4. So now we need to expand this out. So we're going to, when we multiply this, when we square this, remember this is r cosine theta minus 2 times r cosine theta minus 2. So we've got to FOIL this. We're going to do the first terms, then the outside terms, then the inside terms, then the last terms. So we're going to get r squared cosine squared theta minus 2r cosine theta minus 2r cosine theta plus 4. And we can combine those minus 2r cosine thetas. So we get r squared cosine squared theta minus 4 r cosine theta plus 4, and then this squares to r squared sine squared theta, and that all equals 4. All right, now we've got a 4 on both sides, so if we subtract 4 from both sides, those will all add to 0. And now let's also move this negative 4r cosine theta over to the other side, because what we want to do is isolate these r squared terms. So if we add 4r cosine theta to both sides, then we get r squared cosine squared theta plus r squared sine squared theta is equal to 4 r cosine theta. Now we can factor an r squared out of this. We get r squared times cosine squared theta plus sine squared theta is equal to 4r cosine theta. And the reason that this works out nicely for us is because cosine squared theta plus sine squared theta is just 1. That's one of our Pythagorean identities. So we get r squared times 1, so it's just r squared, is equal to 4r cosine theta. And then if we divide both sides by r, we're left with r equals 4 cosine theta, which is what we got doing the graphing method.